Hello dear students, today I will discuss the question answers and numerical problems from the chapter Light, Reflection and Refraction from class 10 based on NCERT syllabus. So let's start the video. Before we start, let me say one thing. Still, who has not viewed the previous video of this chapter, please check the link given in the description box below. At first, let us discuss the question answers as given in the page number 168. So what is the first question? Define the principal focus of a concave mirror. Now write the answer. So, answer is the light rays that are parallel to the principal axis of a concave mirror converge at a specific point on its principal axis after reflecting from the mirror. The point is known as the principal focus of the concave mirror. Now pause the video and write the answer. Now the next question is, the radius of curvature of a spherical mirror is 20 cm. So what is its focal length? As shown in figure, let us consider a concave mirror. As given in the question, the value of the radius of curvature is 20 cm. We know that the focal length is always half of its radius of curvature. This we have r equal to twice f or f equal to r by 2. Since the value of r is 20 cm, that's why f equal to 20 divided by 2, that is 10 cm. So value of the focal length will be 10 cm. Now pause the video and write the answer. Now the next question is number 3. Name the mirror that can give an erect and enlarged image of an object. Write the answer. When an object is placed between pole and the principal focus of a concave mirror, the image formed is virtually erect and enlarged. The next question is number 4. Why do we prefer a convex mirror as a rear view mirror in vehicles? Now write the answer. Convex mirrors give a virtual erect and diminished image of the object placed in front of them. They are preferred as a rear view mirror in vehicles because they give a wider field of view, which allows the driver to see most of the traffic behind him. Now let us discuss the example 10.1 as given in page number 170. So the question is, a convex mirror used for rear view an automobile has a radius of curvature of 3 meter. If a bus is located at 5 meter from this mirror, find the position, nature and size of the image. Now let's discuss the solution. Now see what kind of mirror is given in the question. The mirror is convex mirror. So let us remind the conditions for convex mirror. When the object remains at infinity, the position of the image will be at the focus behind the mirror. And when the position of the object remains between infinity and pole of the mirror, then the position of the image will be between pole and focus behind the mirror. Both this case, the position of the image will be behind the mirror and nature of the image will be virtual and erect. Therefore, the answer of this question also be virtual and erect. We know that the distance of the object is always denoted by u and the distance of the image is always denoted by v. Since the position of the object is always in front of the mirror, so for any kind of numerical, the value of u is always negative. If the image formed in front side, that is left side of the mirror, then the value of v will also be negative. And if the image produced on the back side of the mirror, then its value will be positive. If the object height that to be measured lies above the principal axis, its value to be taken as positive. Similarly for image also, if the image lies above the principal axis, then its value is taken as positive, and if it lies below the principal axis, then it is taken as negative. Now see the answer. The value of radius of curvature is 3 meter. So why it is taken as positive? Since the image formed on the back side of the mirror, so any value on the back side of the mirror always taken as positive. but the object distance is always taken as negative, since object always lies in front side of the mirror. Now we have to calculate the image distance and height of the image. The focal length we have f equal to r by 2. From this we can calculate 3 divided by 2 equal to 1.5 meter. Now we have mirror formula 1 by v plus 1 by u equal to 1 by f. From this formula we can easily calculate the value of v as shown in the picture. The value of v is found to be positive, that is plus 1.15 meter. This means that the image formed on the back side of the mirror, since it is positive. Now we have magnification formula m equal to h dash by h equal to minus v by u. So for mirror it is minus v by u, and for lens v by u only. So by putting the value of v and u, finally we got the value of magnification m equal to plus 0.23. The positive sign of the magnification indicates that the image is visual and erect. Now the next question is example 10.2. An object 4 cm in size is placed at 25 cm in front of a concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and size of the image. So here the object distance is given 25 cm and focal length is given 15 cm. From the focal length we can calculate the radius of curvature capital R equal to 30 cm. Since U is 25 cm, that means that it lies between center of curvature and focus. So let us remind the conditions for concave mirror according to the position of the object where the image is formed. When the object lies between center of curvature and focus. When the object lies between center of curvature and focus, image will form. Beyond center of curvature, nature of the image will be real and inverted, and size of the image will be larger than the object. So similar case will happen for this numerical also. So according to question, the object size h equal to 4 cm, the object distance u equal to minus 25 cm, the focal length f equal to minus 15 cm, and we have to calculate the image distance v and the image size is this. So from mirror formula we have 1 by v plus 1 by u equal to 1 by f. From this we can easily calculate the value of v, and finally the value of v equal to minus 37.5 cm. The negative sign indicates that the image will form in front side of the mirror. Now using the formula of magnification, we can easily calculate the height of the image, and it is minus 6 cm. The negative sign of the image indicates that it is below the principal axis, that is, it is inverted. In the question, height of the object is given 4 cm, but here we can see that height of the image is 6 cm. This means that the image form is enlarged. Now the next question is from the page number 171. The number 1 question is, find the focal length of a convex mirror whose radius of curvature is 32 cm. So it's a very simple question. R equal to 32 cm. So R equal to twice F. Using that formula we can easily calculate the value of focal length F equal to R by 2. That is 32 by 2 equal to 16 cm. Next question is number 2. A convex mirror produces 3 times magnified enlarged real image of an object placed at 10 cm in front of it. Where is the image located? Now write the answer. The formula for magnification, m equal to h by h dash equal to minus v by u. Use the formula. According to question, the size of the image is 3 times larger than the object. So here h dash will be minus 3h. Why it is minus 3h? Because the image form inverted below the principal axis. So it is minus. Now putting the value of u minus 10 cm, we can easily calculate the value of v equal to minus 30 cm. So negative value of v indicates that it is inverted and formed in front side of the mirror. Now see the question answers as given in page number 176. Number 1. A ray of light traveling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal? Why? Now write the answer. The ray of light bends towards the normal. When the ray of light travels from optically rarer medium to optically denser medium, it gets bent towards the normal. Since water is optically denser than air, a ray of light traveling from air into water will bend towards the normal. Now write the next question. Number 2. Light enters from air to glass having refractive index 1.5. What is the speed of light in the glass? The speed of light in vacuum is 3 into 10 to the power 8 meter per second. Now write the answer. The solution is very simple, just have to put the formula n equal to c by v. Using that formula we can directly calculate the value of v, speed of light in glass. Now pause the video and write the answer. Now the next question, number 3. Find out from the table 10.3 the medium having highest optical density. Also find the medium with lowest optical density. So at first see the table 10.3 from the NCERT book. We know that higher the value of optical density, higher is the value of refractive index. So see the table, whose value of refractive index is more. See, diamond has a highest value of refractive index, that is 2.42. That means it has higher value of optical density. On the other hand, you see air has the lowest value of optical density. That means its value is only 1.0003. Therefore the answer is highest optical density is of diamond and lowest optical density is of air. Next, number 4 question. You are given kerosene, turpentine and water. In which of these does the light travel fastest? Use the information given in the table 10.3. We know that the refractive index n equal to c by v. That means v equal to c by n. That means the speed of light in a medium is inversely proportional to its refractive index. That means if the refractive index value is higher, then the speed of light in that medium is less. So it can be observed from the table 10.3 that the refractive indices of kerosene, turpentine and water are 1.44, 1.47 and 1.33 respectively. Therefore, light travels fastest in water. Next, number 5 question. The refractive index of diamond is 2.42. What is the meaning of this statement? Now write the answer. The refractive index formula, we know that n equal to c by v, where c is the speed of light in vacuum or air. So the refractive index of diamond is 2.42. This suggests that the speed of light in diamond is reduced by the factor 2.42 as compared to the speed of air. Now pause the video and write the answer. Now let us discuss the next question from example 10.3 in page number 182. A concave lens has focal length of 15 cm. At what distance should the object from the lens be placed so that it forms an image at 10 cm from the lens? Also find the magnification produced by the lens. At first you see what kind of lens is given in the question. The lens is concave lens. So for concave lens we have two conditions. You just remind it. The first condition is when the object remains at infinity. When the object remains at infinity, the image will form at focus. The second condition is when the object remains between infinity and optical center. In that case, the image will form between focus and optical center. For both this case, the image will be virtual and erect, and that image will form in the front side of the lens. That means on the left side. That is why for this case, the object distance and image distance both are in the front side, that is it is negative. Since both the images are formed virtual and erect, that means that it is always above the principal axis. So height of the object and height of the image both are positive. According to the question, the value of V is 10 cm and F is 15 cm. So both of the value is negative because it lies in front of the lens. The value of U also negative. We have to find the value of U and magnification M. Therefore, in this case, image distance V equal to minus 10 cm, focal length F equal to minus 15 cm. Using the lens formula, we know that 1 by V minus 1 by U equal to 1 by F. Using that formula, we can directly calculate the value of U. And finally, we got the value of U equal to minus 30 cm. Minus sign indicates that the object is placed in front of the lens. Now we have the magnification formula for the lens, M equal to V by U. And mind it, for mirror it was minus V by U. For lens it is V by U only. So finally the value of magnification is plus 0.33. The positive sign of the magnification indicates that the image is virtual and erect. The size of the image will be smaller than the size of the object, that is, it will be 1/3 of the size of the object. Now let us discuss the example 10.4 from the page number 183. A 2 cm tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 cm. The distance of the object from the lens is 15 cm. Find the nature, position and size of the image. Also find the magnification. So at first you see what kind of lens is given. The lens is convex lens. So we have 6 conditions for convex lens image formation. So think yourself what kind of condition, which condition is applicable for this question. See, value of focal length is 10 cm. That means radius of curvature will be 20 cm because double of focal length is radius of curvature. So object distance is given 15 cm, which is less than the radius of curvature but more than the focal length. This means that the object is placed between the radius of curvature or center of curvature and focus. So think the condition where image will form when the object remains between center of curvature and focus. When the object lies between C and F, image will form beyond the center of curvature on the other side of the lens. So this figure will applicable for the question. Therefore, in this case, U will be negative, V will be positive, H is positive and H dash is negative since it is inverted below the principal axis. Thus, using the lens formula 1 by V minus 1 by U equal to 1 by F, we can easily calculate the value of V, which is 30 cm. Positive sign of the V indicates that the image will form on the other side of the lens. The value of the magnification will be minus 2, which indicates that the image form is inverted and real. By the formula of magnification H dash by H, we can calculate the size of the image, which is 4 cm taller than the object. Now let us discuss the questions from the page number 184. The first question is define one diopter of power of a lens. So write the answer. Power of a lens is defined as the reciprocal of focal length. If V is the power of a lens of focal length F, it means that V equal to 1 by F. The SI unit of power of the lens is diopter and it is denoted by D. You already learned about that. Now to define one diopter, we have to write like that. One diopter is defined as the power of a lens of focal length 1 meter. That means 1D equal to 1 meter inverse. Now the next question is number 2. A convex lens forms a real and inverted image of a needle at a distance of 50 cm from it. Where is the needle placed in front of the convex lens if the image is equal to the size of the object? Also find the power of the lens. At first you see what kind of lens is this. The lens is convex lens. Now see what values are given. So here image distance is given 50 cm. So we have to find what is the object distance. And another condition is given if the image is equal to the size of the object. So for convex lens we have 6 conditions. From that 6 conditions, you think yourself in which conditions the size of the object and size of the image both are equal or same. The condition was when the object remains at center of curvature, image will also form at center of curvature, and the size of the object and image both are of equal size. So for this question, that diagram will applicable. Now see the solution for this numerical. Now the next question is number 3. Find the power of a concave lens of focal length 2 meter. So here you see what lens is given. It is concave lens, and we have 2 conditions for concave lens. Both the conditions image will form in the front side of the lens. That's why the value of the focal length will always be minus or negative in case of concave lens. So, using the formula P equal to 1 by F, we can easily calculate the value of power. The value is minus 0.5 diopter as shown. So dear students, today's class is over. In the next class, I will discuss the remaining question answers of this chapter. Till then, bye, take care, and thanks for watching.